Good afternoon and welcome to the second week live interactive session for this NPTEL course Transition Metal Organometallic Chemistry Principles to Application. So already we have covered the week 1 content in the last interactive session, and before starting with the week 2 question answer, that is problem solving session, please wait 2-3 minutes if anybody joins. Otherwise we will continue this session and will upload it. Hope it will be helpful for solving your assignment problems in the portal, or it will give you some knowledge of, or you will get an idea what type of question can be asked in the final examination. So I will wait for a few minutes, then I will start discussing this week questions. I will wait for 2-3 minutes and then I will start to see if anybody is there or not. Okay, so welcome to this week 2. Okay, welcome to this week 2 live interactive session. If you have any doubt or for this last week content, you can directly ask me. We'll first solving your doubts, then we'll start this today's session. If you don't have, then I will continue with the today's question answer session. Okay, if you don't have any doubt, then let's start the today's session by solving some sample questions which is based on the last week content, that is the week 2 content. And by solving the question, I will explain the question in detail so that you will get an overall idea how the question are solved, and in the final examination how to approach the question. So when discussing the question, the one question may have multiple. You need to remember that this in this question uh, you may have multiple selection type answer, multiple answer type question, that is the MSQ, multiple selection question, where there is more than one option is correct
Yes, sir.
for this question. Do you have any doubt? You can directly tell me, otherwise I will start the session by solving the question answer directly.
No doubt, sir. You can continue.
Okay, so okay, so the first question is the today's session is, how many new CO stretching bands is observed for the following complexes? Question is, I think, visible. So this question is related to that organometallic compound and some especially metal carbonyls. So when the question is this, and this type of question also are easy to see in NET or GATE examination. So how many new CO stretching band or S bands is are observed in the following complex ApCO5? Do you have any idea how to solve it?
No, sir. Like I'm yet to see those sessions, sir.
Okay, then so for when this type of question is there, so if you they provide a formula, so first is you have to draw the structure, or you have to know the structure of this complex. So you can see that 5 ligand is there, so 5 CO ligand which are identical. So for FeCO5, or you can write ML5, ML5.
Yes, sir.
So there can be two structure possible. Which are they?
Two structures.
Two
Is it fact
geometry.
and null?
Two geometry can be possible.
Two geometry.
Hmm.
Do
One
I have to
is,
say the point group?
no, not point group. Like we have that like square planar, tetrahedral. We are saying like that. Trigonal, bipyramidal, octahedral. So which
Yes, sir. It should
geometry?
be TBP.
So yes. So what is the other one? TBP is trigonal bipyramidal.
Yes, sir.
What can be the other one?
Can it be pentagonal bipyramidal?
Pentagonal bipyramidal will be pentagonal, means it will be 5 plus bipyramidal is 2. So 5 plus 2, that will be 7, not 5.
Okay, sir. Oh, okay, sir.
Okay. There will be like trigonal bipyramidal you say. So trigonal bipyramidal means trigonal is a plane and bipyramidal means another is the above, another is the below. So 3 plus
Yes,
2
sir.
equal to 5. So another geometry or another is possible, which is square pyramidal. Okay, so let's draw the two structures. So if that is the L is a ligand, so L you can have 4 ligand in a plane, and another L should be can be in the above. So here it also satisfy the ML5 structure. So another
Yes, sir.
is, as you say, that trigonal bipyramidal. So L, L, 3L will be in a triangle, and another two ligand will be above and below. So this can
Ah,
be
yes, similar to
three,
PCL5 structure.
huh? Two structure is possible. Now the question is how many CO stretching band. So so and here for FeCO5 this is not the correct structure. The correct structure will be the trigonal bipyramidal. Okay,
Okay, sir.
so for the trigonal bipyramidal, how to calculate the or how to find the number of CO? So here you can see, so here all L are CO ligand, that is the carbonyl ligand. So here
Yes,
you
sir.
can see that 3 CO ligand, that is the 3 CO ligand which is in the plane of this paper. Okay, that is
Yes,
in the
sir.
triangle, and another 2 are in the axial.
Axial. Yeah.
Axial. Okay, so here basically you can say that two types of CO moiety is present. So 3 CO in the plane of the paper and another 2 is the above and below of this triangular plane. So
Yes, sir.
here two types of carbonyl frequency will be observed. Okay, so the correct
Yes.
answer will be 2.
So why
Yes.
two? Because there are two ligands which are like axial to each other. That's the reason why
Yes, two
given
ligands are
two.
actual to each other. That that will give one stretching, that is symmetrical. Another three which is in the plane, that will give one stretching. That basically
Okay.
I have meant to say that these three ligand which is in the plane of the paper are equivalent. Another two which are in the axial, that are equivalent. That's why two types of signal is observed.
Okay, sir. That is one signal for equivalent and one signal for axial.
Yes.
Right?
So
Okay, sir.
this idea is coming from the, or if you read the group theory in detail, you will get an fine idea how point group, basically what will be the point group for this molecule.
One group. Is it C3V?
So let's say an octahedral molecule is there, let's say Ml6. So here for Ml6 molecule we will have another L ligand here. Okay, like this.
Yes, sir.
So here you know that for the octahedral geometry all 6 positions are same,
Yes,
right?
sir. Yes, sir.
So here for octahedral molecule you cannot distinguish the square planar or the axial, that is the equatorial and axial you cannot distinguish. So here
Yes, sir.
all 6 ligand are equivalent for octahedral. So that's why for Ml6 octahedral geometry there will be only one CO stretching frequency. But when the symmetry decreases, let's say if you remove the one of this L ligand, then the
Yes, sir.
symmetry decreases from more symmetrical structure to less symmetrical structure. That's why
Yes,
the
sir.
number of CO stretching band will increases. That means the non-equivalent CO, non-equivalent carbonyl group will be increased in the structure, will give different signal in IR band. So there is a table, and the idea is totally not that theoretical idea, it is totally calculated from the group theory. So but
Yes, sir.
it is very difficult to calculate in this type of competitive exam. So there is a table. So next day I will show that table, and according to the different point group, one they have allotted the how many number of CO you can calculate for any structure in general. So next day we will provide that. So okay, so let's go to the next question. Next question is the CC bond.
Sir, one more doubt, sir. So for octahedral, you mean to say like there will be only one stretching frequency?
Huh,
Okay, sir.
here.
But if you remove one CO, which means there won't be any stretching frequency obtained.
Huh. So the idea
Yes.
is not for the octahedral but any tetrahedral. If you see
Hmm.
the all CO ligand are equivalent. So I draw the octahedral like this. So if you draw octahedral like in the other way, like let's say, let me draw it again. How you can say that this is equivalent? So this is the plane which I am drawing. You can see the plane.
Yes, sir.
Now this, I have not changed the position of the ligand.
Yes,
All
sir.
the ligand position are same, but the
Yes,
square
sir.
plane which previously was, now it is different plane. But
Yes, sir.
here then axial ligand is this. Okay,
Yes, sir.
that's why in octahedral geometry all 6 ligands are equivalent. But here,
Okay, sir.
like for this molecule, you cannot draw the structure like this. Okay,
Yes,
so
sir.
let me in more detail here. Mhm. Now let's say another plane. Hey, this is another plane which we were talking previously, and here this is the another axial ligand. Okay,
Yes, sir.
so now all the ligands are same, but if you consider the square plane, square planar and axial octahedral, there is no difference. You can consider it all the ligands are same. That's why only one CO sequence will be observed for octahedral complexes. If all, and here the condition is all L6, that means all ligands should be same, not different ligand.
Yes,
Next
sir.
day, like as I started with this, the next day or also, like next Sunday, I will start with this with a diagram or with a table which it will clearly indicate how many stretching frequency will be there. Okay, the next question is, the CC bond in transition metal sigma alkane complex is weakened by. So this week has started with, we have started reading the sigma alkane complex. Alkane means metal is bound to a carbon atom C, which is sp3 hybridized.
Three hybridized. Yes, sir.
Okay, now the CC bond in transition metal sigma alkane complex is weakened by. That
Yes, sir.
means we are talking about this CC bond.
Yes, sir. Correct, sir. CC bond.
Okay, now how this bond will weaken?
How is based upon the coordination with metal atom?
Now you have 4 options.
Okay, okay, sir. Ligand to metal sigma donation. Is it option C?
So
Hello.
here you can see that there may be more than one option is correct. So first option says that metal to ligand pi donation, ligand to metal sigma donation, metal to ligand pi back donation, and metal to ligand metal to ligand sigma donation.
Sigma donation.
Now when the sigma donation happen from ligand to metal.
Ligand to metal.
So
Yeah.
if this carbon is donating its electron to the metal, then obviously this bond will be weakened. So the one option will be the metal to ligand, ligand to metal sigma donation. So option B will
Donation.
be the correct answer. Another
Okay, sir.
option is, so option B is the one of the correct answer. Okay, so
Okay,
another
sir.
option you can say that when metal to ligand pi back donation, that means if metal also donates its electron to this carbon atom, then what will happen? So maintaining the electroneutrality or that overall coordination, this bond electron will be partially moved to this carbon atom. Okay,
Yes,
then
sir.
also weakens this CC bond. So here
Okay, sir.
both option B and C will be right answer. Okay, is it clear?
Yes, sir. So what happens is initially if the carbon donates electrons to the metal atom, what happens? It forms a bond, whereas the other carbon, with the second carbon gets weakened. That second CC carbon that gets weakened.
Hmm.
But if metal is electron rich and it back there and it donates the electron back to the ligand, so what happens is the CC bond is likely to break up for sure.
Hmm. Hmm. Not break up, it will weaken.
Like okay, weaken. Okay,
Okay.
bond will weaken. Yeah.
Bond will weaken. Okay.
Okay, sir.
Now question 3 is, in case of metal carbonyl, identify the correct statement. In case of metal carbonyl means we have already discussed MCO5 or MCO6 or MCON, whatever, metal
Yes,
carbonyl.
sir.
So this question is whatever you have answered in the last question and related.
Yes, sir.
This is that the sigma bond arises from the overlap of sp hybridized electron pair on carbon atom on CO with empty d orbital. Filled d orbital of the metal back donates is pi orbital of carbon atom of this CO, and option C is CO is a poor pi accepting ligand, and option D is metal is metal is high oxidation state is necessary for the formation of metal carbonyl compound. Now we are considering last year is M C double bond O.
Yes, sir.
Okay, so read one by one. Options. Options A says that A sigma bonds arise from overlap of sp hybridized electron pair on carbon atom of CO with empty d orbital. Obviously, so the metal d orbital will be empty, so that
Yes, sir.
it can
That's a Lewis
accept the
method.
electron pair from the carbonyl. So, okay, so
Yes, sir.
option number A is the statement is correct.
But sir, one more doubt. Like here it is mentioned sp hybridized electron pair. So how it should be sp3, right? Like when carbon forms a bond with the metal atom, it forms only sp3 bond, right? Not sp.
No, this is metal carbonyls. Metal alkyl complex is different, which we will talk in
Okay,
that
sir. Okay,
video.
okay.
This is metal carbonyls, MCO.
Yes, sir. Okay, sir. Okay.
Okay, when it is CC,
Okay, sir.
like the previous one it was MCC,
Oh, okay, sir. Yeah, yeah. Got it, sir.
and this one is MCO. That is we are talking
MCU.
about
Okay,
metal
yeah. Okay.
carbonyls,
C. Okay. So
because
triple bond.
metal
Okay, sir.
carbonyls is more important.
Yes, sir. Yes, sir.
So this bonding pattern you will have to understand more detail. That's why I put this question in this week. Okay,
Yes.
the sigma bond in case of metal carbonyl, the sp hybridized electron pair on the carbon atom of this. So next option is filled d orbital of metal. The metal also have some electron in its d orbital which is filled, donates the pi orbital, donates links back donate pi star orbital of the carbon atom of CO. So also this is also correct, because the metal also have some electron and it donates it to the carbon atom as a back donation. The effect is called synergism, synergistic
Synergistic
effect.
effect. Yes,
Okay,
sir.
that
Synergistic
means the
effect.
sigma bond, the extent of sigma bonding will increase the extent of pi bonding. So this
Yes,
option
sir.
B is also the statement is correct.
Yes, sir. Correct.
Now option C, the CO is a poor pi accepting ligand. Is it correct?
No, sir.
CO is a good pi accepting ligand.
Yes,
Okay.
sir. It's a good by accepting.
So this statement is not correct.
So because like CEO is able to like it can do pi back donation, that's the
Yes.
reason why it is actually good pi
It can
accepting ligand.
accept electron in its anti-bonding pi star orbital.
Pi star orbital, yes, sir.
Okay. So CO is a good pi accepting ligand.
Yes,
And
sir.
the option D is metal in high oxidation state is necessary for the formation of metal carbonyl compound. We know that for the metal carbonyl compound, this back donation is highly important.
Important. Yes, sir.
If the metal is high oxidation state, metal in high oxidation state, that means plus 3 plus 4, when carbonyl or carbon donates his electron to the metal, is it possible to donate electron again, it is back donate
No,
electron to the
sir.
carbon?
No, sir. Not
It
possible.
is not possible. That will, it will attain the electronic saturation if it is high oxidation state. So back
Yes, sir.
donation is not possible for
Not
metal.
possible, sir.
So this option D is also wrong.
Wrong, sir.
So what we have to find in the answer? In case of metal carbonyl, identify the incorrect statement.
Incorrect statement. Yes,
So
sir.
both
C and D are incorrect
so
statement.
option C and option D are incorrect statement. That will be the right answer. So in the exam, please be assured or read question correctly, that you have to find the incorrect statement, not the correct statement. So we may
Yes,
be in
sir.
hurry or solving the question in last 5 minutes, 10 minutes. Sometimes we may miss these types of question also. So that time you should read that statement of this question very carefully, whether you have to find the incorrect one or the correct one. Okay. So this is a very important trick or very important thing to remember during the examination. So option C
So
and
one
D.
doubt.
Huh.
So one more thing is like need not necessary that the metal has to be high oxidation rate, because metal can also be either in zero configuration, zero oxidation state, or like +1 or +2 oxidation state, like low oxidation state. Then only like the backbone can be favored.
Hmm.
Okay, sir.
So here the statement say, you do not get it. See, let's say the option C. Statement is
Hmm.
wrong. Statement is wrong.
Yes, sir.
Like you read the statement. Statement says that metal in high oxidation state is necessary for the formation of metal carbonyl compound. That means the
Yes,
statement
sir.
say that metal should be in the high oxidation state for formation of metal carbonate. That is wrong.
Yes,
So
sir. That I know.
so what is your doubt?
So what I am trying to say is, if metal is in low oxidation state, then there is a possibility of back donation
Yes,
taking place.
yes.
That's
If
what I
the
was
metal
asking.
is
Okay,
in
sir.
zero oxidation state or plus 1 or plus 2, then only the formation of metal carbonyl is possible. If metal is in high oxidation state, is it difficult to form a back donation? Then that's why it is not possible for the metal to form a carbonyl complex.
Yes, sir.
Okay. The next is, the next 2-3 questions will be like this type of question, which is the formation of metal alkyl complex. Okay. So
So,
this question is, when you are getting this question or reading in the slides or in that PDF, try to understand each of the reaction or most of the reaction what is happening here,
yes, sir.
and then try to get your answer. Let's say here it said that we have a complex, it is a molybdenum complex. Molybdenum complex, what kind of ligand it has? It is has a CP ligand, cyclopentadienyl ligand. It has 3 carbonyl group,
Yes, sir.
and
One
it has
hydrogen.
one, not hydrogen, you should say the hydride.
Hydride. Hydride. Yes, sir.
Hydride, that means H minus.
Hmm.
Okay, now you have this reagent, what it is called? This reagent is very famous and we call this diazomethane compound.
Yes, sir. Diazomethyl.
So this compound is readily has the N2, nitrogen 2. So when we heat or in presence of light, is readily removes the nitrogen, and this readily from the CH2. This is carbene, and carbene is highly nucleophilic or electrophilic.
Carbon is electrophilic, sir.
So electrophilic, that means it
Yes.
requires electron. So when we heat that think this diazo compound, it will leave this carbene moiety which is electrophilic in nature. Where we have electron? We have electron
between molybdenum and hydrogen, MOH bond, we have
in
electrons.
hydride.
Yes, hydride.
Hydride is highly
Electron
nucleophilic in
rich.
nature or have the high electron density in that molecule or in that atom.
Yes.
So it will easily capture this hydride and it will form CH3. Okay.
Yes, sir.
So what will be the now right answer? So here you can see that is triple bond chain, that is a nitrene complex. This is an azotype complex. It is a molybdenum carbene complex or a molybdenum alkane complex. So what will be the right answer?
Molybdenum alkane complex.
Yes. So option number D will be the
D.
right answer for this question.
So only thing is here CH2 carbene will get inserted between molybdenum and hydrogen bond. Am I right?
Yes. So
From
when
yes.
this type of question or equation you read or try to find the logic how the reaction is happening. Sometimes it is not easy to find the reason for every reaction, how it is happening or why it is happening, but most of the cases you can find it out. For that way
Yes.
you can remember the equation when it is asked in the examination. So these two reagents are there. The role of this reagent is to perform this work, another reagent is to perform this work. When this is together, this will should give this product. Every time some exception is there, but in most of the cases you will get the right answer if you go logically.
Yes, sir.
The next question is predict the product of the reaction.
Okay, sir. Yes,
CEO. So this is the question number 5. This question number 5. This reaction is started in the slides one step backward. So when I will go to the slide, I will discuss this question again. So what will happen to this? When the iron 2 carbonyl and 1 acyl group it attached is presence of H nu, what will happen? And also sometime you can calculate the total valence electron count for that complexes.
This one I have doubt. This one I have doubt in this question, like how the product, what will be the product?
Okay. So now, what will be the product? Let's say, in what is the total electron count for this complex?
Okay, so can I just write and let you know?
Electron count is iron. So iron will have 8 electrons.
8 electrons, yes, 8 electrons.
Then CP ring have 5
Have 5 electrons.
2
Beta 5.
carbonyl will have 4 electrons.
4 electrons.
And this ligand will have 1 electron.
1 electron.
That means
18 electrons, sir.
So that means the complex satisfy the 18 electron system.
Yes, sir.
Okay. So whatever happens, the 18 electron will not break. That means
Yes,
some rearrangement will happen in this system.
Yes, sir.
Okay, so what will happen? So, so one CP ligand which is highly strongly bonded with the iron, which will not leave the system. So iron will have it CP ligand. Now what can we leave? Let's say CO or in this moiety. So here the leaving tendency of CO is greater. So CO will leave here. So that means in presence of light, one CO molecule will leave from the system, and this CH3CO group, that is the acyl group, will undergo a rearrangement, and it will form a CO, CO and CH3 alkyl complex. Okay, that means this CH3 is is going to this iron, and one of the CO moiety is removing from the system. That means a rearrangement is happening in this molecule.
Sir.
So here then there are also the 18 electron rule is obtained. So H nu means high energy. So when you give high energy to this molecule, the rearrangement will happen. Okay.
Sir, I didn't get, sir, one second. Like option will be answer will be option D. Am I right? So like one more thing, can you just explain once again like how did because of this photon condition decarboxylation happens, so that's why we get FeCH3 bond.
Huh.
Okay, sir.
Okay.
Okay, sir. Okay.
Now predict the product of this reaction.
Yes.
So here it's a iridium complex with two phosphine ligand, one halide and one carbonyl. So when it will react with methyl chloride CH3Cl, what will happen? Let's take a look at the option. Now you can see that here we have four coordination, that is you can say it is a square planar complex, and we are adding methyl chloride, that means CH3 plus Cl minus, let's say in that way. So what will happen? So 4 plus 3, 4 plus 2 methyl chloride, that means 6. So coordination number can be increased to 6, or like the previous question we see that CO molecule or the bromide which are highly labile group, it may release from the system to maintain the coordination, or it may be 5 also. So here what will happen to this when the iridium complex undergo the reaction with methyl chloride?
So here there will be oxidative addition they will be taking place, right?
So what will be the product?
Option D will be the product.
Option D will be the product. Why
Yes,
not
sir.
option A?
So because iridium is having a tetrahedral complex. So if the CH3 and Cl attacks on this one, it forms an octahedral complex. So there is no chance that it can form trigonal bipyramidal. Like there won't be any elimination of this carbonyl.
There will be no elimination of carbonyl because the condition is not like that. Also,
Yes,
if you
sir.
calculate the total electron count of this, what will be the total electron count before and after?
Okay,
like
sir.
for this one and this one.
Okay, sir.
For iridium, what is the system?
Iridium, it will be like 9 electrons.
9 plus
Because cobalt group, right? So
2 phosphine, that will be 4.
4
And then 1 CO,
plus,
that will be
plus
2.
1 carbonyl, so 2 electrons.
Then there will be
Bromine will contribute 1 electron.
chlorine and methane, that will be 3.
3.
Then
No, sir, once a bromine will contribute only 1 electron, right?
bromine, chlorine and this methyl CH3.
Okay. Okay, sir. Okay. Together you are saying 3. Okay. 1 plus
Yes,
1 plus 1 3. Yes, sir.
that will be
18, sir.
18.
Yes, sir.
Okay, that is the also reason that option D will be the correct answer, because it is forming a
Yes, sir.
18 electron species. And if you
Yes, yes.
calculate that this one what will be? 9 plus 2 plus L is also 2 plus 3.
It will become 16 electron complex, sir.
Yes, so all of that will be less than 18. That's why the more stable 18 electron complex will be the major product for this reaction, or exclusive product for this reaction. Also,
Yes, sir.
when we observe the reaction is called the oxidative addition.
Yes, sir.
The reaction is called the oxidative addition.
Oxidative addition. Yes, sir.
So one thing to note or to observe in this reaction, when oxidative addition or reductive elimination happen, these generally undergo by cis fashion. Okay,
Okay, sir.
when the oxidative addition happen, the oxidative ligand like this ligand CH3 and Cl is generally add in a cis orientation, but here in this case it can see that it add in a trans fashion, so we call it is a trans oxidative addition,
Okay, sir.
because this CH3 and this Cl are trans to each other.
Okay, sir.
Okay.
Like, sir, before the oxidative addition, like the complex will be in cis fashion, but
Ah,
after the oxidative addition reaction, then it will become trans.
yes.
Okay, sir.
Now oxidative addition I say in terms of the moiety which is added. You got it or not? Here both the
No.
phosphine, if you say the phosphine ligand in terms of, here both are trans to each other, and also in
Yes,
the
sir.
product they are also trans to each other, so that are not changing. Only
Okay,
changing
sir.
is that the moiety or the ligand which is attaching to it,
To iridium. Yeah.
to iridium, whether these two, that is CH3 and Cl, are cis to each other or they are becoming trans to each other.
Yes, sir.
Okay,
They are becoming trans, sir.
they are becoming trans. That's why we say it is a trans
Trans
oxidative addition.
oxidative addition.
Okay. Next is question 7. The Tolman cone angle describe. Tolman cone angle is a very big parameter or difficult, but in general what is described? The bond length in the phosphine ligand, size of metal
Yes, sir.
complex as a whole, size of metal ion, or
I
size
did.
of the ligand.
So is it size of metal ions?
Okay, so Tolman cone angle generally describe the steric factor. So when we go in a 3D metal series, like especially from iron, cobalt, nickel, copper and zinc, like say from cobalt to nickel, you can see that there is an increase of only one electron thing. That means the metal and its electron is one electron increase in the same orbital will not increase the overall size of the metal. So if when we are considering the steric effect, we generally describe the steric effect of the ligand. Metal steric effect come when we are changing the orbitals, like from 3D to 4D to 5D. There the steric effect coming for the metal. But Tolman cone angle does not describe that metal, whatever it is. It describes that size of the ligand. For the same metal, the Tolman angle represents how that amount of a area of a cone is occupied by a particular ligand. So here that two options is confusing. One is the size of the metal complex as a whole, another is the size of the ligand. So but the metal complex, the overall metal complex does not play any role in the cone angle, a Tolman cone angle, but the ligand has a role because each of the ligand has different cone angle which described by this Tolman.
Yes, sir.
So option D will be the right answer
Good
to
answer.
this question. So
Okay, sir.
you can see that means the overall size of a complex, but it is not the overall size. That different ligand size is described by Tolman cone angle.
Yes, sir.
Next
Like
is
for each and every bulky ligand, there will be different cone angle associated for
yes.
it. Fine,
As
sir.
the size of the ligand increases, that Tolman cone angle will increase. Tolman cone
Increase.
angle you can say is a parameter to describe that ligand bulkiness.
It is directly proportional to size of the ligands.
Yes.
Okay, sir.
Okay. Now here is the another question which is like the similar question which I discussed in the first question. It says that how many CO stretching band or S is observed in the following complex CrCO5 PME3. Again, when this type of question is there, so first you have to know the structure of this. Sometime, in most of the time, the structure is given for easy understanding, but here you have to give the structure. So here the corresponding we can write M L 5 X, which represents this molecule, right?
Yeah.
M is the chromium, L here is a CO ligand, and X is another ligand which is PME3.
Trimethyl phosphine.
So for this ligand, for this configuration, what can be the structure? Let's say we have 6 ligand, so here it will be M all the L will be, and one of the L will be below and X will be above, right?
Yes, sir.
What can be the other possible way to write? It can have M L L X and okay.
Yes, sir.
So here in this system all 6 ligand are not equivalent, non-equivalent, because you have 5 same ligand and one X which is different ligand. So this is not an octahedral system. Geometry is octahedral, but the system is not an octahedral. Okay,
Yes,
because
sir.
all same ligand, all the 6 ligand are not same. So in this case you can see that all 4 L are equivalent. So that means that will give one CO stretching and another L is axial, that will give
Yes, sir.
one.
Yes, sir.
Okay, here also these two are axial and these three are planar,
Yes,
2
sir.
axial and 3 planar. So that will give overall 1 plus 1, 2 different kind of CO. But That means here 2 plus 2, 4 types of CO stretching can be possible.
Yes, sir.
But that because of the superimposable, or as that one become equivalent, that means one of the CO stretching frequency, let's for this planar molecule, let's say for example, and these three planar become equivalent. So actual case we only observed the 3 CO band, not the all 4 observed. Okay, so in reality we observed only 3 CO band, not 4. So
Why sir 3 CO bands?
that means one among 3, 2 are overlapping.
Okay, sir.
That means
Okay, sir. Like there are two bands, but two bands are overlapping to form a one band. Okay,
that
sir.
means
But this
in
for that
reality,
the other one case, right?
yes,
Second one. Okay, sir.
that means 3 in total, 3 CO are observed.
Okay, sir.
Next day slide I will provide 2 pages where this this type of formula will be given and corresponding number of carbonyl band will be there. Okay, so and you can convert any of the metal complex which is given, you can convert to this formula and you can calculate, or you can have an idea how many CO band will be there.
Yes, sir.
The next question is question 9. The valence electron count for rhenium in Re2CO10.
CO10.
That is a very easy question. The total valence electron count.
Yes, sir. Let me just do it, sir. Okay, sir. Total valence electron, I'm getting it 34 electrons, sir.
It says that valence electron count for rhenium. That means for one
Rhenium.
rhenium.
Okay, sir.
So
For
if
one rhenium, okay, sir.
okay, so for that the question sometimes be difficult or to understand. If the question say total valence electron count,
Okay, sir.
total valence electron count, then you can say the total valence electron count for this overall moiety, overall compound. But the question says that valence electron count for rhenium. That means for one rhenium center, what is your valence electron count?
Yes, sir. Okay, so once again, so is it option B?
Option
B? B for
yes,
ball.
option B. So what is the structure of this molecule? So here, as I told earlier, that rhenium, or like the heavy heavy metal carbonyl show the formation of breached carbonyl is
Yes, sir.
very limited, or it is not possible to form for the 5D metals because they
Yes,
are
sir.
very large. Okay, so here all the carbonyl group, that is the 5 carbonyl, 1 2 3 4 5 6 7 8 9 10,
Like everything will be in terminal position.
every carbonyl will be terminal and there will be one rhenium bond. So so rhenium is in which series? Isn't it manganese?
Manganese. Manganese
It will
series.
have 7 plus, it will have, you can break it to ReCO5.
Yes, sir. 10
So then 7 plus 10
plus
plus
1 electron from
1
metal metal
electron
bond.
for the metal metal bond, that
It
will give
forms
you
18.
18 electron. Okay, so take a note of it, that when the question says that valence electron count for rhenium, valence electron count for metal, you have to consider only one metal center. But if the question
Yes, sir.
says that total valence electron count, then you have to count the valence electron for overall metal center. That will give you to 36. So
Yes,
total
sir.
valence electron count will be 36 and valence electron count for one rhenium is 18.
Yes, sir.
Okay. The next question is, the upon oxidative addition the central metal atom would, is a statement type question, and this is also
Percentage central plating will increase the
upon
formation.
oxidative addition the central metal atom would increase the coordination number by 2, decrease the coordination number by 2, decrease the oxidation state by 2, and increase the oxidation state by 2.
So one option is increase the coordination number by 2. Option A.
Option A. Okay. And what about the oxidation state?
Let me just check, sir. I think I've done this question like for earlier as well. Like
Hmm.
for iridium complex, we've done, right?
We have done that as an example. Now it is a statement. A similar question can be asked in two ways.
So I think D will be one more option.
Yes, D will
Yes.
be one more option. So this
Yes.
question is a type of MSQ.
MSQ.
In the question or in the final question also there will be, or in the portal also there will be some MSQ type question. So for MSQ type question you don't know whether it is MSQ or whether it is MCQ. So if
Sir.
you read this question at first, that's for oxidative addition the metal center metal atom would, you first read option A, that increase the coordination number by 2. Yes, option A correct. You go to the next question, but you don't read, you may sometimes that other three options. So when the exam, in the exam you have both MCQ and MSQ, always read all the four options in
Yes,
any
sir.
exam. Always read all the four options. If you get your correct answer, sometimes the questions become very easy, like this question. So you, and for that easy question you always get the correct answer in option A or option B, so that you do not go or read the option C and D. Okay, so always
Sir.
read all the four options in all competitive exam where both is possibility, MCQ and MSQ. Okay, The next question is option 11. That is the this question is the synthesis of preparation of metal alkyl complex,
Yes,
and there
sir.
is also a special name name the reaction.
Grignard reaction.
No,
Oh
read
no, sir. Grignard
read
reagent is used, sir.
Grignard reagent is used, but the reaction is not the Grignard reaction.
Oh no, sir.
Grignard reaction is an organic reaction, but here what
Yes,
is
sir.
happening, you see.
Like CH getting replaced by getting attached to that metal atom. It is CH2 pH get attached to zirconium. It will form the option C complex. That is ZlCH2
Yes,
pH4.
this is not D, this is C.
Yes, sir.
C. Huh. So that will form a tetra benzyl. The PHCH2 is called the benzyl.
Yes, sir. Benzyl. Yeah.
Benzyl. So that will be tetrabenzyl zirconium
Zirconate
complex.
ion.
So what is the name of this reaction? You can see that this benzyl moiety here in that magnesium, which is a metal, now it is
Yes, sir.
transferred to the another metal, which is zirconium. So
Yes, sir.
what is this called? This reaction is called the transmetallation reaction.
Yes, transmetallation reaction.
Okay. So this reaction is
Yes, sir.
called the
Transmetallation reaction.
transmetallation reaction. Okay. I think with this we have completed the 11 question in this topic, in this today's week 2 topic. Do you have any other question regarding
Yes,
this?
the last question I just have one doubt. That is, in the case of transmetallation reaction, what happens is like whenever like a zinc complex makes a reaction, it forms a transmetallation reaction, right?
Hmm.
So in that case, like zinc is getting associated with the atom. That is, say if there is a atom called CH2Br, so when we react with zinc, it forms CH2ZnBr. So where C gets a negative charge, whereas zinc gets a partial positive charge.
Hmm.
That is actually a Reformatsky reaction, if I'm not wrong. So this is also one more example of a transmetallation reaction.
Hmm. There are so many
Okay,
examples. I can show you in the slides.
okay,
That's
sir.
one example I have picked up for this question.
Okay, sir.
Okay. So when we open that one PDF that I shared, hmm, in the last day I show you how to download it. So when you open that PDF, I will show 1 minute. I will share it. 1 minute.
Sure, sir.
This one, huh? This is the PDF of the whole lecture, which you can download and read. If you don't want to read the video, you see the video, but I suggest to watch the videos because that thing is more explained, and
Yes, sir.
here everything is written. Whatever is there in the video, everything is written here.
Okay, sir. Okay.
In this, it will
Like it's
get
like a compiled document.
yes.
Okay, sir.
So you get it, and you go to that thing. Yes. So here you can see that there are a lot of examples where the transmetallation happened.
Yes, sir. Okay, so it's metathesis reaction. Okay.
Yes, metathesis reaction, also called the transmetallation reaction.
Okay, sir.
Transmetallation reaction is basically when that ligand is attached to one metal, and after the reaction the same ligand will be attached to the another metal.
Yes, sir.
Okay, so this is called the transmetallation reaction.
Yes, sir.
And the last day, and here you can, this question you can also say that alkene insertion mechanism or hydrometallation reaction. This is the past reaction. This reaction
Yes, sir.
also I discussed in the one of the question, that here they say there is a olefin or alkene, that ethylene is
Yes,
there,
sir.
and here hydride is there. So hydride is negative, so it will attach to the olefin and it will form the sigma alkene complex. So that is an alkene
Yes, sir.
ethyl group. Here also you
You
can
say
see,
this is about diazomethane, right? Maybe that
that
example.
I show for the diazomethane because this partner was different. That is a diazomethane, but
Yes, sir.
that is but also same. That is also electrophilic in nature. Here olefin also is electrophilic, so it will takes up
Yes,
this
sir.
one of the hydrogen and get reduced and form this metal alkyl complex. Here also
Yes, sir.
olefin is there, so it will also takes up this hydrogen as a hydride, and this form this alkyl complexes.
Yes, sir. Like what, sir, when this 1T-butadiene is reacted with the iron complex, what happens is it forms two products, right? One is actually that
Yes, because of
olefin which
that
is having
rearrangement.
trans formation and cis
Ah,
formation.
so because of the rearrangement of the cis and trans, both product can be
Yes, sir.
formed.
Yes, sir.
And this is that question which I already discussed. And when the diazomethane, that is the N2 nitrogen eliminates from the system, is formed the carbene. So carbene is
Yes, sir.
inserted into the metal hydride bond to have these alkyl complexes.
Yes, sir.
And here this question is also important, that when this manganese Mn2 CO10, like that rhenium we have discussed,
Yes, sir.
just discuss the total electron count of the rhenium. Here it is the Mn, manganese. Like instead of rhenium we have manganese, but in case of manganese also it don't have that bridging structure. Okay, in solution
Yes, sir.
state structure it is all are terminal. So
Yes,
when
sir.
you can see that sodium and mercury. So what is the role of sodium mercury?
So it's like a reducing agent,
It
sir.
is a
Sodium
reducing
amalgam.
agent. So that means it will give the electron to the system.
Yes, sir.
That means it become donates 1 electron to the mamen, and now you can see that in manganese is 7, and then 1 2 3 4 5 6 5.
Yes, sir.
So 5
Yes, sir.
is,
5 bonds.
that is 10 electron, and
10
manganese is 7.
electrons.
So 7
Yes, sir.
electron, and one of the extra electron coming from the reducing agent, that is the sodium mercury.
Yes,
That
sir.
is the reducing agent, so that will provide the electron. That will manganese become negatively charged,
Negative charge, minus charge, yeah.
minus charge, and which is counter ion is sodium.
Sodium
That
plus.
will undergo the oxidative addition. Here you can see that a oxidative addition, it is the alkylation, and here the methyl will add to again from the 18 electron complex. Okay.
Yes, sir.
And in the last lecture, this question which I saw, that is the question number 5, I told you that this is the acylation reaction. When this iron complex will undergo, then see that iron complex is also negatively charged.
Negative charge.
Iron is 8,
Sir, yes, sir. 8 electrons.
8 electron plus 5 plus
5
4
electrons plus 4.
plus 4.
Yes, sir.
That means how many total electron?
17, sir.
17. Then it
Yes,
undergoes,
sir. Minus charge is above, plus 1 electron.
plus 1 electron is
18
18.
electrons. Yes, sir.
Then it negatively charged, so this iron center will undergo this acyl chloride and it will give this acyl moiety. But this acyl moiety is unstable, and in presence of light it will eliminate one CO and undergo the rearrangement to have this metal alkyl complex. Because
Yes, sir.
in the irradiation condition or high energy condition, the CO elimination is very common.
Yes, sir.
Okay. And this iridium oxidative addition we also discussed.
Yes, sir.
Now, which I did not discuss, that is a similar problem with the iron. You can see here that one cobalt center is there. Okay. Now, when
Yes, sir.
it undergo the oxidative addition, because of the 8 electron rule, it leaves the iodine as a I minus, as leaving cobalt as a 3. Now, what will happen? This CH3 and this CO again will undergo the rearrangement or insertion. You can say that carbonyl insertion into the metal alkyl bond. That is, the carbonyl will inserted into the metal alkyl bond to give this acyl moiety, and then iodide will bound to this to have this complex. This is the just like the reverse case which we discussed for the iron.
Yes, sir.
Okay.
Sir, cobalt plus 2 change into plus 3, right?
Yeah, cobalt here is a plus 1 oxidation state.
Oh, sir, yeah, 1 to
That
change into
is
plus 2. Okay, sir.
changing to plus 3. When
Yes,
oxidative
sir.
addition happen, the oxidation state will be changed to plus 2. There is an increase in oxidation state by plus 2.
Yes,
That was
sir.
also a question today. Okay.
Yes, sir.
So when for the oxidative addition, but here you can see as the 18 electron rule is violating, so that oxidative addition does not increase the coordination number by 2. Okay, which we told you that when we do the oxidative addition, coordination number increase by 2, but here the coordination number doesn't increase by 2, it increases by 1 only. That's why it further undergo the rearrangement and gives the final product. Okay.
Okay, sir. Got it, sir.
Because throughout the reaction that throughout the reaction it maintains the 18 valence electron configuration.
Yes, sir. Got it, sir.
Also, this nickel question is important. And I think I have covered most of the topic. Now the last day we have discussed that electronic configuration, right? How that 22
Yes, sir.
electron came. So that day we
Yes, sir.
only considered that pi pi sorry sigma bonding ligand, but we did not discuss the pi electronic configuration ligand having the pi contribution. This
Yes,
is the
sir.
molecular orbital diagram when you have all the ligand which is purely pi orbital or pi character in nature,
Yes, sir.
like the CO here. Here the molecular orbital, this I saw in the last class. This here you can see that all the molecular orbital or all the ligand orbital are purely sigma dominating, not pi accepting. So pi
Yes, sir.
orbital that is dxz, dyz এবং dxy remains at anti a weakly bonding or non-bonding in this system. But when we have a ligand which gives the pi contribution like the carbonyl moiety or CN cyanide moiety, then the molecular orbital diagram changes little bit. So
Yes, sir.
there also we can see that molecular orbital diagram for sigma and pi bonding. So what changes will happen here? The changes is when we have the pi bonding or pi orbital contribution from the ligand, this pi orbital contribution, it will interact with
Yes,
the
sir.
pi character orbital from the metal which is T2G. Because of this
Yes.
interaction, you can see that when the pi orbital was here,
Mm.
when we have the pi orbital here in this position, and now because of this thing of the pi contribution from the ligand, it will intergo and the bonding orbital will stabilize, and anti-bonding pi orbital or T2G star orbital will destabilize. As the T2G orbital was purely non-bonding in nature, now it will provide a bonding contribution, and that the energy gap between the T2G and EG will increase. So from the molecular orbital we can say that when the orbital have the pi electronic configuration, like the pi accepting configuration, then it will that bonding non-bonding T2G orbital become bonding and it will stabilize, and anti-bonding orbital will be more stabilized. Now the energy gap between the T2G and the EG star will be increased. That's why
Yes,
the
sir.
pi accepting ligand have more ligand field strength or more delta O value. Okay, so you can draw this thing in the PPT. That will be a better understanding. not going to that thing, presentation mode. Presentation mode. Okay, let's draw it here only. Okay. So when that, so we have that orbital, metal orbital D, S and P, and here we have the ligand orbital 6. Okay, here we have 5, here we have 3. So when the sigma donation is there, we will have the T2G orbital, which will have 3 here, 3 orbital here, T2G. Okay, and here it will be EG and EG star, EG and EG star. This is for the sigma bonding orbital only. But when we have pi contribution, let's say for the same, we have and another 6 pi orbital will be here. So now this pi orbital will interact with the T2G, which will have a pi contribution. So EG and EG star will be here, EG and EG star. This is pi. But this T2G orbital is now interact with this pi, and this T2G will be lower down, and this will be so now if you consider EG, now if you consider the delta value, this one and this one, obviously for the pi accepting ligand the delta value will increase. That's why that for the pi accepting ligand the delta have a, or crystal field delta value, or the difference between the two level will increase, which can be also see from this ligand. That's for the strong, we say that strong field ligand have more delta value. This is the thing
Okay, sir.
which was remaining from the last day. So in the upcoming days we will also try to some so in the next day we will start our discussion with that metal carbonyl, or how many staging frequency will be there, with a table which I will provide. And in that followed by the next week content, that is a sigma alkyl complexes. And another questions which was asked in that previous session, that that the binding mode of different complexes, which is also very important. So for the binding mode, when we consider that, let me go to that thing, binding mode, like that metal binding. Yeah. The binding of the metal complexes, binding modes. Yeah. Okay. So here this mode is also very important. So when the metal is bind to an phenyl moiety, here you can say it is an aryl metal aryl. But when it is M double bond Cr, that we call a carbene or alkylidene. So when the metal bonded to the carbon atom with double bond, we call this alkylidene or carbene. So when there is a dene, that is DENE, that is the last three word is ENE, that is a metal. That means metal is bind to a carbon atom with the two bond. Okay, but when in the next page, when is
Okay, sir.
metal is bound to a carbon atom with three bond, we call this alkylidene. DYNE. So YNE or ine. They are like that alkane, alkene and alkyne. So for that the same thing for metal alkane complex, metal bound to a carbon atom with single bond. Alkene complex, metal or is called metal bound to a with double bond, and then is a triple bond. So you have to just see the last three words, then you can see or you can understand what is the binding mode of the metal with the carbon. So this thing which
Okay,
was
sir.
a doubt which was asked in the last session, that is the last year, so we cleared it.
Okay, sir.
Or there is also some different kind of binding like the terminal binding, three center binding. So this, from this part, some question may be asked. How the question can be asked? That they will provide different kind of binding and you have to choose the correct binding. Let's say for terminal binding mode, so you have to choose the correct terminal binding. Then sometimes the sidewise binding mode, like different binding mode, just need to remember. Okay, so next day we'll go
Okay, sir.
start with the lecture 11 and we'll read in more detail with that sigma alkyl complexes, and we will perform some reaction. We will some reaction as an example like that today we discuss. So when you read the reactions, so it is better that you don't read or don't memorize the reaction. Try to understand the reaction, basically what is happening, so that when the similar kind of reaction is coming, just change the substituent, you are able to answer. And the 80 electron rule is a very important, or you can say it is a fundamental rule for organometallic chemistry. Sometimes it may not follow, but most of the cases it follow. Let's say that cobalt oxidative addition question. In generally we see that the oxidative addition the coordination number increases, but for here because of the 18 electron rule restriction the oxidation number doesn't increase. Later on we undergo a rearrangement and then perform the substitution or oxidative addition reaction. Okay, I think we have discussed most of the important topic. Next we will read some beta hydride elimination reaction starting from the in the week first lecture with the beta hydride elimination reaction and its consequences. So uh, if you have any doubt you can ask me other than this course or other from chemistry perspective, or we'll end this session in few minutes. Okay.
Sir, I've sent something in the chat box. Will you please check it out?
It's loading actually. I don't know what is the problem. You can just say there is that chat box is loading, it's not opening.
Yes, sir. What I want to say is like where you're taking the coaching for NET GATE exam.
Yeah. What? Oh, what is?
What I'm trying to say is where did you take coaching for NET and GATE exam?
Oh, where I took the mat coaching.
Yes, sir.
Oh, I qualified NET in 2020. 2020. So that time online coaching was not very common. It was common, but it was not that much popular like this. So if you
Okay,
want to
sir.
take coaching, will definitely say that please go for any online coaching instead of offline, and practice at your home, and that is basically I think more than enough to get your degree, to get your result. But thing is that you have to
Okay, sir.
keep practicing. Now as per my knowledge or as per my experience, now the as per the question pattern it is not about your deep knowledge, how much deep you know on a topic, but something you have to like know everything. Okay, the connection is lost. You can watch it on the live session or live recording. So let me tell you the question, the answer. It got disconnected. Is disconnected for some reason. So okay, the question was asked is for that coaching purposes. So for that NET and GATE, it is better to take. I think that online coaching. if the offline coaching is very far away from your hometown or where you live, so otherwise you can also join that offline coaching if it is convenient. But from for convenient for everything, it is more about you have to practice. You have to practice more and more questions on a particular topic to get this thing, get the more questions, to connect with the more questions or more different kind of question, which is better. And now the scenario is that for competitive exam, they the cutoff is very high, so instead of getting a knowledge on a deeper knowledge on a particular topic, you have to get small knowledge on all of the topic. So which will, let's say for that 50% knowledge on all of the topic, instead of getting a complete knowledge on a topic, that is 100% knowledge on a particular topic. So that will increase your score to get that thing for your net or any competitive exam. And one thing that the, solving more and more problems in regular basis is the only way to qualify the exam, other than reading textbooks for the long time. Solving the questions, understanding the question, and if you are expert in some area, if you get that question wrong or tick wrong answer, then just to rectify it, how can you make it right? So that is the more important. And another thing that you have to like more test, time based test you have to give to get your question clear. So as that things get offline, so I'll connect it with the next day and we'll discuss for that. Thank you. And whoever will watch this session from that recording sheet, I will ask them please join in that live session, and you will get your doubt cleared, and I will try to explain as detailed as possible. And the next day we'll see you.